have these steps visually displayed in the class on a piece of chart paper that you can move around and you can preserve for subsequent lessons, future days. You might not write these precise words. You might instead write examples that are representative of the steps. But the point is there's explicit steps that kids could follow that you can model when you're solving these problems. Notice next that in this lesson there are problems that are listed, different types of ways you could round numbers. And they include some thinking that goes into it. There's the I do it phase. That's when the teacher is the model learner. The kids are listening and they're watching, but they don't necessarily need to write in their math journals because that's a lot of cognitive load on them when they're just learning things. And then you see after the I do it, in which teachers model, there's questions in which the teachers and the students do it together. Call that the we do it together phase. And you might have kids thinking and pairing and sharing with their A-B partners, and you might use popsicle sticks to randomly select them. And you can see it's the same types of problems that you modeled in the previous phase of this lesson. So you get the kids interacting with each other, they're interacting with you, you're able to check for their understanding, you're able to correct any emerging errors, get them on the right path. Notice also in this phase there's a whiteboard check. What's the point of this? Well, wouldn't it be great, here we are midway through a lesson, to know whether 80+% of our kids are with us and which kids aren't with us. This could really help us determine the rest of our lesson. And basically what I mean is, if when you ask these 2 whiteboard questions, it doesn't have to be 2, it could be 1, it could be 3, but when you ask these whiteboard questions, you're going to be asking kids to do these problems independently, without your help, without anybody else's help, because you want to know what they know about halfway through the lesson. Let's say 50% of the kids don't get it. Well, then you probably don't want to release responsibility to the class. You probably want to revisit how we solve these types of problems. But let's say, which is I'm sure the case most often, that 80% plus or minus a few percent, 80% of the kids are demonstrating mastery. Great. Then those 80% of the kids are ready to move on. But 20% thereabouts probably aren't ready to move on. So you, while the other kids are working in a group or independently, you can meet with that small set of students and provide more guided support to them because they're not ready to go to greater levels of responsibility. So that's the purpose of these whiteboard questions. Scrolling on down, here I've planned for problems that the kiddos can do in groups. It's the you do it together phase. So teams of 4, teams of 2, they could be working on these. They could be solving the problems together while each of them records it in their journals or math notebooks. They could be solving them by themselves, but know that you've told them they can ask their table mates for assistance. The point is you want to be freed up to meet with students requiring more support on the carpet or on a back table or something. I've selected here in this lesson 7 problems. Very similar to the problems that we've modeled for them. A couple of them are a little more advanced, but they're problems that we've deduced the kids can do without us. Then you can see there's the you do it alone phase, and you might access a worksheet, or with our older kiddos you might ask them to copy 6 to 10 problems in their math journal so that you don't have to copy an entire sheet of problems for them. Regarding these worksheets, y'all, and we're going to talk a lot more about this, but we don't need to assign a worksheet every day to kids. We certainly don't need to assign a 2-sided worksheet that each has 20 problems. Assigning 6 to 10 problems for students to solve at night is definitely sufficient. So imagine a 2-sided worksheet, each with 20 problems on it. That 2-sided worksheet could be used for 4 days worth of homework. Or, as I said earlier, you can have older kiddos copy down problems that you've written on the smartboard or pre-written for them to solve as homework. The other huge caution, you guys, is we should not be assigning homework that kids can't do independently. If we have evidence that there's some kids or most kids who need more support, who aren't ready to do it without us, then we probably shouldn't be assigning that type of homework. So what do? Well, maybe we don't assign homework that day. Or maybe we assign problems that are from previous days lessons for which we have evidence that they can do independently. Maybe it's math facts type of reinforcement that is an appropriate type of homework. But let's not just assign homework to assign it, and certainly let's be super prudent with our use of paper and worksheets. Worksheets don't teach kids. Worksheets don't grow dendrites. That's us, and that's us through participative and interactive work. The other things you're going to see in these lessons, time permitting, is that it would be great if you give kids opportunity to talk to other kids, student teaching student. So these problems that you've had them solve while you were working with a small group, provide an opportunity for them to check their answers with their table group and have them be able to share the ways in which they've solved problems with their peers. And then similar, time permitting, select random students to come up and solve a few of the problems that you've assigned to them for their entire class. This is valuable time. Not only is it a wonderful check for understanding for you, because you get to listen to a child explain their reasoning and their problem solving, but their classmates and you also perhaps get to hear about alternative ways of solving problems, which is fantastic. It's something to be celebrated. Wow, you might say, you found a new way of doing this problem. Tell us more about that. That's great. The last part of the lesson, and this is something we really want to make a non-negotiable, is an exit slip. So even if you don't get to other parts of this lesson plan within the time that you have, do close your lessons with some type of exit slip, ticket out the door. Could be a verbal, oral share out. But the point is, let's get evidence about who has demonstrated mastery and the extent to which they've demonstrated mastery. So you can see here that the exit slip for this lesson is just a problem, a sample problem that we would hope that kids would solve in relation to, scrolling back up, the objective of the day, the why do it. Okay. So going back to the math map itself, I want to point out to you that given our smart boards, our Promethean boards, we really have an opportunity to do something exciting with technology that will obviously save paper, but also make for a pretty dynamic lesson. And I'm talking about IXL. So let's say that we are rounding numbers in IXL. And that's the objective of this lesson. So we could click on this IXL link during the I do it phase. So I'm modeling for kids here. So I have this displayed on my smartboard, and in the blank space provided, I can use my smartboard pens to apply the steps. Maybe I have these steps posted on a portion of the smartboard. Maybe they're posted on chart paper next to the smartboard. But I'm able to think aloud and actually solve this problem. And then I can get the answer correct and say, oh, I believe this would be 40 if I rounded it to the nearest 10, after I've thought about why that's the case, etc. And I can solve that problem. Look, it presents a new problem for me. That can be another problem that I solve. Or I can go back to the map and solve a different type of problem. But let's say I want to continue with this. And it says surround to the nearest 100. I can think through the way to solve this problem, and I might make an error. Wouldn't that be fun? And I could say that it's 500. And IXL will say, no, that's not correct. Here's an explanation. And so it's a good sort of sample and model. But IXL really has that functionality, which is quite nice. So going back to the map itself, what I wanted to point out is that when you're modeling problems for the students, you can use IXL with your smartboard. When you are solving problems with the students and you're asking the students to think about how to solve the problem, to tell their paired partner about how to solve the problem, and then you're randomly calling on kids, you can also use the IXL problems off your smartboard. Just a really wonderful tool that we could be utilizing. Now, during the subsequent phases of the lesson, you might not be able to use IXL because it will only present a single problem at a time, but you can certainly use your smartboard to display, let's say, the 6 to 7 problems that you're going to ask students to solve with their table mates while you work with a small group. So we really want to take advantage of the technology and what will do for us, not just to save paper, that's significant, but also to really tap into the interactive qualities of technology. So that's a a brief but hopefully helpful description of how I plan a lesson. As always, you can email Anthony or I on our Distinctive Schools Google Mail, Gmail account, and I will be present on campuses 2 full days a month. And I would love to plan lessons with you. I would love to teach lessons with you or for you that kind of shows how you can plan a lesson and turn that lesson into a actual executed lesson for kids.